built a mitochondrial genome back, which I'll use as a backbone. I checked the tree. It's generally quite good, apart from the base, which is low supported, so that needs a bit more information. I'll do that a bit later. I've obtained DNA barcodes from Bold, processed these, aligned them. And I'd like to build a species level phylogeny incorporating both of these. Now I checked the overlap, and I noticed there's a lot of stuff missing. So these in the white, or these are the species from the mitochondrial genomes. So I've just checked, done a grep to see if these are in the barcode alignment, and surprisingly a lot of them are not. You'd assume if something's so widely studied that someone's sequenced the mitochondrial genome, that someone would have also at least done some barcodes, which is a lot easier, but these have not been submitted to Bold or not been done. Even I noticed this one, Phytomia zonata, which is extremely common, and even this is not on Bold. So there's is it insufficient barcode data from Bold. So a job I will do now, which we will go through now, is I would like to incorporate NCBI data also, barcodes from NCBI, and we'll see if there's more on there. So to obtain NCBI barcodes on the command line, we can use these set of tools. We've got, I think this is called eUtilities. These are command line tools to interface with NCBI. So we've got using eSearch and eFetch. eSearch does a query. So this is similar to the text queries that you'd use on the normal web interface for NCBI. So searching for this particular fact, this is the subject for this project. It's a particularly interesting family. I find it quite interesting. So search for the family, ORGN, organism, field, and COI, colon. We can put some dates in there. We fetch faster format. And so I've done this once. I got some error message. So I've done it again, and I will assume it's now run correctly. So let's go to, okay, so we have an output faster file from Bold. Now we'll search for co1. We can't assume that they're all co1 for several reasons. It's only searching for the string and not necessarily strictly the assigned gene, and also of course there's different fragments of code. There's 2 fragments, 5' and 3', and there could be even full length columns. And we all need the barcode marker, which is 5' co1. So there's still some more processing required from this output, in addition to processing the IDs. So first, let's take a look at the file list. So we can use cat just to look at the output on print the output to the screen, and this gives the full faster output. And we use grep to print only the ID lines, which are faster delimiter is the forward arrow. So we do string search and we're just printing the ID lines. So the faster format's retrieved from NCBI has a very verbose ID line. It's got accession, taxonomic assignment. Well, this is a full description line. Description, which includes the description of the marker and a taxon, and even the specimen. So most of this we don't need. We just need the genus, species, and accession is enough. So we need to process these IDs. So it's a bit of a myth that people develop code or always developing new code. Actually, for the most part, we're repurposing and previous commands. We're not reinventing the wheel all the time. So somewhere I will have previously processed these ID lines. So it's just a matter of finding where I've done this previously. So I'm going to check this bit of text which I've been working on for some time, and see if I can find the command I've used for parsing these IDs firstly. And this looks promising. I see a set command working on a blast output. So let's insert our file name we're working on now, and so you can see the file we have has accession, genus, species, and a bunch of other stuff. And the sed command is searching for first word, space, well, first string, which is not a space. We've got a word, space, second word, space, third word, and these are being rearranged, and the remainder is just being cut off. So we have, then this is being replaced with item with match 231, 2 being the genus name, 3 being the species name, then 1 being the accession. So this looks like, I think this is what we want here. So let's copy this in. Yep, this looks nice. So we're going for this very verbose output to nicely arranged, standardized format. So this is a new command which we put into our set of commands as we build our pipeline. So we pipe this screen output into a new file. We'll call that fast2. So this file is now processed. We'll process the IDs. Now we have to incorporate this into the bold data. So this is the NCBI data, and we will integrate it with the bold. So here we've just processed the IDs. Now I think what we want to do next is we'll do a blast search just to confirm that these are actually col1 5'. There could be some very long sequences or something. So I think here we need to insert a blast search. Okay, so here we have where are we? So for the blast, so with blast we'll use this is a file of standard colon barcodes, and we will blast this new file we've got from bold and see what these are. Yeah, I'm just looking a bit confused which would be regarded the query and subject in this case. So I think we'll have a subject as set from bold, and then the reference. Okay, it's maybe a bit reversed, but anyway. Out. We'll rename the blast output. Percent identity 60 needs to be quite low. Don't need many targets, or do we? Do we need targets? I'm not sure. Okay, we'll just try this and actually thinking about it, I think we do need a lot of targets, because so our query we're using standard colon barcodes. So these are for various insects, and the subject we're using our barcodes from bold, and we're going to retrieve. So there could be only one from this family in this subject, or one very similar, which will be hitting many, and that would preferentially hit our new NCBI barcodes. So we're going to need a lot of maximum targets. We're going to set this to a high value. So it's just actually just to check how many we've got in this file. So this command just checks faster entries. So we have 18,000 from sequences, which should be colon from bold. So we match the ID lines and just count these with word count. So it's always worth keeping records of how many sequences we have at each stage, because we often, as a project develops, there'll be improvements, bug fixes, repeats on updated databases, so this number often changes. So just keep records of how many sequences we're dealing with. But this means we need so maximum target sequences I'm going to set to 20,000. And I'll run this blast again. Okay, while that's running, so we're going to retrieve all sequences, anything hit, which is kind of a confirmed colon 5'. We want to retrieve that sequence, and I'm pretty sure I have commands to do this. So we can use a cut command to just extract the column. So I'm going to interrupt this, Control C, and instead of working on the full output, I think we'll still establish the subsequent steps and on the partial output. So first let's look at the output from this blast search. So we've specified using the out format switch for blast n, we can specify exactly what to write in the output table. Query, sequence ID, subject sequence ID, e-value, percent identity, and alignment length. So particularly we need the subject sequence ID, which is the second column. Yeah, and luckily we have this simplified format, so we can use the cut command to pull out one column, cut to the next command. So these are everything we've obtained from NCBI, which has been hit with the standard colon 5'. So this is confirmed as the exact fragment we need. And these are the IDs we then need to obtain from this. Now there'll probably be multiple hits. We have multiple queries just for taxonomic coverage, but that means the NCBI barcodes will be reported several times over the whole output file, and so we need to we don't want to retrieve these sequences several times, so we need to probably use the unique command. We need to sort and unique. Let's just find this. I did write this somewhere here. Okay, here we go. It's probably this one. So we are catting so just displaying the contents of the blast output file. Now unique Linux command actually only works on sorted files. If you don't sort them, it doesn't work properly. So we need to use sort also, then pipe that into unique. So let's just check this. Actually, first we need to cut also, so we just need the second column. Cut, pipe that into sort and unique. Okay, let's try this. Yep, you can see these are sorted, and these are no duplicates here. Okay, good. So we'll just put this into a file we can then use. So these are, yep, go1 home logs. This name is fine, I think, and not used elsewhere. Okay, so we have a list of IDs which are now confirmed column 5'. Finally, we need to retrieve these from the original file which we downloaded. So yes, blast dbcmd will do this, but I think we need to also make this into a blast searchable database, and somewhere will be must be this here. Here we go. So here's our complete file. Turn this into a blast searchable database, then retrieve the subset which are confirmed colon barcodes. Yep, so this looks fine. So we get in the retrieve list of IDs, put them into this file, homolog IDs. Then we're using the entry batch command for plus dbcmd, which retrieves a list of IDs. Entry batch retrieves a list from a file rather than specifying the ID list on the command line, which is better when you have a lot. Then we have the blast virtual database here. Okay, that looks okay. Let's try this. Yes, we forgot to make the file. Try again. File is not accessible. Homolog IDs 2. Okay, name is slightly different. Yep, this seems to be working. Unfortunately, it seems to have added a few characters for some reason. I'm pretty sure these were not in the. I don't know why it's LCL and this character. Yeah, these are not in the files. It's just added these for some arbitrary reason. This is quite irritating when software does this. So we just need to remove those. But otherwise, that's working. We can. Yep. Pipe this into a new faster file. A few missing, but otherwise here. And we just remove this little string. We will use sed just to trim that off. So just copy it. And replace it with just the arrow, effectively deleting it. And put into a new file, fast2. Have a look at this. Okay, looks fine. We'll check it a bit more, maybe check it a bit more thoroughly. Open in a text editor. See if there's anything else strange we notice that we might need to deal with. In particular, yeah, I'm looking at some. These sequences seem a bit longer, so we may need to account for. In fact, we may better off just be removing long sequences. So the DNA barcode fragment should be about 700 base pairs. Makes it a bit awkward. And something else I just noticed is a space been introduced after the ID that may cause some issues. We need to deal with that. And maybe we would just also delete the full length barcodes and just deal with the standard 700 base pair fragment. So I can introduce a step to check for sequence length. Yeah, I see some very long sequences here. Also, not some issue. So there'll be no additional steps to deal with. I think we'll check for sequence length also. So let's make a note what we need to do. Move long sequences. And we'll also remove spaces from IDs. But otherwise we now have core1 barcodes from NCBI we can append to our bold barcodes, and I think that will do us for today.